Today we'll be going over the rational root theorem and the irrational conjugates theorem. The rational root theorem. I always say, of course a lot of students do not understand this, but there used to be a saying, mind your P's and Q's. And that's how I remember the rational root theorem, is P divided by Q. Now where do you get your P and your Q from? Your P comes from factor of the constant term. And, we know from factors, here's our constant term. All the factors of this number will be our P's. And then for our Q, all the factors of this number will be our Q. We'll just dive right into examples. I'm skipping over to Student Journal 100 for example number 11. And in the bottom right hand corner this says this is page 61 in our notebook. So I'll skip right over to number 11. According to the rational root theorem, which one is not a possible solution? Well, in this case we're going to do that P divided by Q that the rational root theorem mentions. The P's come from the factors of 7. 1 times 7, -1 times -7. Those are the factors of 7. These are better written like this, plus or minus 1, plus or minus 7. And then the factors of 2, 1 times 2, -1 times -2, better written as plus or minus 1, plus or minus 2. Now, P divided by Q. We have to take all the combinations that we have here. Let's start with 1. Positive 1 divided by positive 1. Positive 1 divided by negative 1. Negative 1 divided by positive 1. I think that took care of all my combinations. Nope, I got one more. Negative 1 divided by negative 1. Okay, then for my other pairs, I've got positive 1 divided by positive 2. And I promise I'll make this make more sense in just a minute. And I've got negative 1 divided by positive 2. And positive 1 divided by negative 2. And negative 1 divided by negative 2. Then let me do the P's divided by Q's with 7. Positive 1 divided by positive 7 divided by positive 1. Positive 7 divided by negative 1. This makes it look like all those fractions are equivalent, but they're not. They're all possibilities of the roots for that problem. And let's see, let me continue. Negative 7 divided by positive 1, and negative 7 divided by negative 1. Then I think I have one more round. Positive 7 divided by positive 2, positive 7 divided by negative 2, and negative 7 divided by positive 2, and negative 7 divided by negative 2. I think that gives me all of them. Okay, so then my possible zeros, or my possible roots, are plus or minus 1. So a positive 1 or a negative is a possibility for a root or a zero or a solution to this equation. 1/2. Let me get my thing so you can see. The positive and negative 1 came from this. 1 divided by 1 is 1. 1 divided by negative 1 is negative 1. Negative 1 divided by 1 is negative 1. 1 divided by negative 1, or sorry, negative 1 divided by negative 1 is positive 1. So positive 1 or negative 1 is a possible root, according to the rational root theorem, for this equation here. Then positive 1/2, negative 1/2, negative 1/2, positive 1/2. So then I can say that positive or negative 1/2 is also another possibility. Then, let's see, where did I leave off? At my 1/2s. Positive 7, negative 7, negative 7, positive 7. So plus or minus 7 are also possible rational roots. And then to finish it off, I have positive 7 over 2, negative 7 over 2. Negative 7 over 2, positive 7 over 2. So plus or minus 7 over 2. Those are the only possibilities that could be zeros to this function here. So that means that if I wanted to do synthetic division, if I didn't have a graphing calculator and I needed to show my work, if I wanted to do synthetic division, I would only have to try 1, 2, 3, 4, 5, 6, 7, 8 of these numbers to find a rational root. I don't have to randomly guess numbers. These are all my possible ones. So let's choose the correct answer down here. Which one is not a possible solution of the equation? 3.5. Is that up here? Yes, positive 3.5. 0.5, or 1/2. Is that up here? Yes, positive 1/2. 7. Is that up here? Yes. 2 is 2 one of the possible roots, one of my p's divided by q's? No, 2 is not. So then I would say that 2 is not a possible solution to this equation. Okay, so I'm going to find all the zeros of this function. I want us to remember that I'm going to do p divided by q, where p comes from all the factors of 48, and q comes from all the factors of 3. I'm going to pause the video, write down all the factors of 48 and 3, and then come back. Okay, so I'm going to do my p's divided by q's. Let me talk really quickly about all my factors. I got this list from doing positive 1 times positive 48, negative 1 times negative 48. Positive 2 times positive 24, negative 2 times negative 24. 3 times 16, 4 times 12, 6 times 8. Those are all the factors of 48. Then for 3, the only thing I can multiply to get 3 is positive 1 times positive 3, or negative 1 times negative 3. So now I'm going to go through, and I'll get you to stay with me for this. I'm going to go through and do my p divided by q. I'm going to make all my list of possible zeros. So I'm going to look at this and say, okay, positive or negative 1 divided by positive or negative 1 is going to be positive or negative 1. Then I'll go through and do positive or negative 2 divided by positive negative 1, positive negative 3 divided by positive negative 1. I think I'll pause this and go through and list all those. Positive negative 8 divided by positive negative 1. All of these are possible zeros. So I'm going to go through and write all those down really quickly. Okay, so I went through and listed all of those. Here's my first round of possible solutions for this function up here. Okay, so then my next round, I'm going to do positive or negative 2 divided by positive negative 1, which it's already there. Positive or negative 2 divided by positive or negative 3. That would be positive or negative 2/3. Positive or negative 1, which I don't need to list that again. Positive or negative 4/3. Positive or negative 2, which I don't need to list that again. Positive or negative 8/3, and remember I'm doing p divided by q. I will list that one. P divided by q. Plus or minus 12 divided by plus or minus 3 would be plus or minus 4, which is already down here. Plus or minus 16 divided by plus or minus 3 is not down there, so I will list that. Plus or minus 24 divided by plus or minus 3 is plus or minus 8, so I don't need to list that again. And plus or minus 48 divided by plus or minus 3 is plus or minus 16. So I don't have a whole lot to list. I'll pause and list them, then come back and explain really quickly again. Okay, so I listed the rest of them, but I drew an arrow right here because I did forget this as I was explaining. I need to do p divided by q plus or minus 1 divided by plus or minus 3. It was not already in this list, so that would be plus or minus 1/3. Can't see the minus on there. I'll put it there in just a second. And then I did these two. That's plus or minus 2/3. Remember, these divided would give me 1, so I don't need that. Plus or minus 4/3, which I'll put here. These divided would give me 2. I don't need that. It's already there. 8/3 is here. 12/3 is 4. I don't need that. 16/3 is here. 24 thirds is 8. It's already in the list. And 48 thirds. Okay, so that means I've narrowed it down from an infinite amount of possible solutions to 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. So there are 30 possible solutions, which does seem overwhelming, but we're just going to take a random guess. Sometimes I'm a good guesser, sometimes I'm not. So I'm just going to randomly guess 4. I don't know why, and I'm going to choose positive 4. And what I'm going to do, I'm going to take positive 4, and I am going to do synthetic division. 3, 11, negative 40, negative 132, and 48. I don't know if it'll work or not. We'll see. And I'm going to see if I get 0 for a remainder. Remember, I'm adding here. I think I'm going to pause so that I don't take up a lot of time to do this, and then I'll come back and show you my result. Okay, well, I did not get 0, so that means that 4 is not a solution. I think what I'll do is I'll erase all this. I'm going to put negative 4 there, and then I can eliminate negative 4. I'll be back to let you know. Okay, so I did get 0 that time. I brought down the 3, got negative 12, negative 1. Pretty sure I did all the math correctly, and I got 0. So that means that negative 4 is one of my solutions. And I tried both of those, so I got negative 4. And then I've narrowed it down to 3x cubed minus x squared minus 36x plus 12. And I may be able to factor that. So let me pause and see. I'm going to factor by grouping and see how that goes. So just let me pause and see. Okay, so I thought it would be able to, and I was correct that time. I could factor this by grouping. I grouped those together, and I got the same here. It won't always work like this. You may have to take this and choose another one of these, which we could have done that. Choose another one of these and do synthetic division until we get a remainder of 0. Sometimes I'm lucky when I guess these. I just guessed 4. I really did just randomly guess. I did not know. So you just have to guess until you find it. And sometimes problems like these fill out my whole paper because I don't erase. But for these notes, I only had this amount of space, so I had to erase. Okay, so let me continue and finish this problem. I can factor this. When I get this factored, that won't factor, but I can do the 0 product property and find my other 3 solutions. So here we go. Let me factor 3x minus 1 times x squared minus 12, 0 product property, and see, you can see here that 1/3 is going to be one of the solutions. So I can put 1/3 up here. And then for this one, I'm going to add 12. Since that won't factor, I'm just going to go ahead and add 12. I'm going to take the square root of both sides. Don't forget your plus or minus. 12 will simplify. So I'm going to have positive 2 times the square root of 3 and negative 2 times the square root of 3. Those are all my zeros for that function. So there's the answer. So these problems sometimes take a long time, and I just want to insert this note. Number 12, you may have to do something like this for number 12 because on yesterday's assignment, because number 12 won't factor. So that's what I was telling a student when they messaged me today. I have a feeling that there's something you just don't know how to do in there. And it did say find all the real zeros. So the other ones in that problem must be complex. And I'm sure that's something we'll get to very soon. Okay, the next thing I want to go over is the irrational conjugate theorem.